So hi everyone. Uncle Michael mentioned, my name is Michael as well. And we're going to be going over a little bit about grade 8 math. Most of my grade 8 students right now, they just finished the unit on sequencing and patterning. So I'm not sure if that's the case for Wendy as well. A lot of the grade 7 students will have done this as well, but a lot of the times they don't ask you to learn about the algebraic expression and the general term. So this is just something that I want to go over a little bit more with all of you, because I do think the sequencing and the patterning is the most important thing going into grade 9 math, okay? Because it is about linear patterning. And in grade 9, you start learning about linear equations. So I do want you to focus on this unit a little bit more on your grade 8 math, because I do think it's the most important thing that you'll be able to use in grade 9, okay? So anytime you have a sequence, you have to learn how to identify it as a graph and figure out the formula in order to calculate that sequence, okay? So this is probably the most important thing for grade 9 math. So that's why I want to go over a little bit more today. Again, if you guys have any questions, you can let me know. Wow, why is that really, it feels really big. Okay. So let's take a look at a very simple pattern to start off. And then you guys can tell me how it is we can identify the pattern and write the equation. Okay, this might be a little bit easy for some of you, but again, I do think it is important for grade 9 math. So for today's lesson, we'll just be going over it a little bit more, okay? So for example, we take a look at this first pattern. We have a 4, 10, 18, 28 pattern. Most of you have probably already noticed this pattern is actually not a linear pattern. So a lot of the times when you guys are doing patterns in school, maybe your patterns will just be something very simple. It might be something like this, like 5, 9, 14, and 19. Now who can tell me what type of pattern, what's the pattern rule for this type of pattern? This one is very easy, right? 5, 9, I'm sorry?
Add 4.
Add 4, yeah, that's correct. But generally speaking, when we talk about the pattern rule and we want to express it in words, we say what number we start at too. So we might say something like start at 5, add 4 each time. Increase is correct, Evan, but again, increase is not enough. We need to specify at the grade 8, at least when we're doing it at the grade 7 level even, we need to say exactly how much is the increase. So usually in school, we would say something like start at 5, add 4 each time. Okay, and that's a very easy pattern. This one is very, very easy to express in words. Who knows how we can express this as an algebraic equation? In other words, with variables. Usually at the elementary level, you guys use n as the term numbers. Okay, yep, Sherry, go ahead.
5, wait, no, n plus 4.
N plus 4.
And then n, wait, yeah, I think it will be n plus 4 and then.
So remember, the n represents the term number. In other words, what is the, what number is the value at, right? So in other words, this is the first term value, this is the second term value, this is the third term value, and this is the fourth term value. I'm not sure if you guys can see my mouse. I should really get used to circling it. But if we use the pattern m plus 4, it works for the first one. 1 plus 4 equals to 5. But you'll see that it starts to break down as soon as we get to the second term. Because 2 plus 4 does not equal to 9. Neither does 3 plus 4. So that means there's something wrong with this equation. This equation doesn't quite represent this, this sequence. Is there another equation that we can perhaps think of which might represent this equation? I think somebody might have thought in the chat.
Is it n2 plus 4 and 3 plus 4?
n2 plus 4?
Like after you did n plus 4.
After we did n plus 4, and then what do we need to do?
Like after n plus 4, isn't it supposed to be like a formula?
Yeah, so how do we write a general formula that applies to every single term? So I kind of understand what you're saying. You're saying that, oh, okay, you just take the previous term and you add 4 each time, but it's hard to write that in a formula. We don't have a way of writing previous terms. So how can we write that using what we know? Does anybody know how we can express this as an algebraic equation? 5, 9, 14, and 19. Any of our grade 8 students? Wendy, you said that you were in grade 8, right? So you probably know how to express this.
I think maybe it will be like first one is 4 plus 1 and second one is 2 times 4 plus 1.
Okay.
And next one is 3 plus 4 plus 2.
3 plus 4 plus 2.
3 times 4 plus 2.
3 times 4 plus 2, 4 plus 2. Okay, so you're saying this one is 4 plus 1, then 2 times 4 plus 1, then 3 times 4 plus 2. So you can see that this is going to get a little bit complicated because we start changing a lot of different variables. So you have a plus 1, then all of a sudden you do plus 1, and all of a sudden you do plus 2. So this makes it very hard for us to write a general equation. I'll teach you guys how to do this one first. And then afterwards, I'll give you another example, and then you guys tell me how to do that one, okay? So this one is actually very easy. When we have a linear pattern, in other words, the increase is always consistent, or a decrease is consistent. So it's always plus 3 every time, plus 4 every time, or it goes down by 2 every time, something like that. It's actually very easy. We just need to calculate how much it goes up by every time. And you guys have already told me, all of you are very smart, you told me that this is a plus 4 pattern. Now that we know this is a plus 4 pattern, and we know that it's linear, oops, somebody wrote it in chat. Is the pattern rule supposed to be adding 4 each time? It is, very good. So that's how we express it in words. So we would say start at 5 and add 4 each time. But now we want to know how to write it as a, in English, in school, they might call it general term, or they might call it as an algebraic expression.
I want to ask, like, is 9 plus 4 equals 14?
I'm sorry, could you say that one more time?
I don't think 9 plus 4 equals 14.
Oh, I'm so sorry. It's a plus 5. It's my fault. I wrote the pattern wrong, so maybe I made a mistake for you. I'm really sorry. It's my fault. So now it's a linear pattern. You're right.
Hello, I never caught that.
No, it's my fault. So it's, I didn't write the pattern properly. So now that we have this pattern, maybe Wendy can tell me what the pattern is then. Yeah, I do apologize to you, Kenny. I wrote the pattern and I didn't add it myself properly. So it's my fault. So Wendy, what's my general term for this one then? Now it might be easier, right?
Yeah.
Lydia raised her hand. Okay, Lydia, did you want to tell me what the pattern rule is?
Is it 4n plus 1?
Yeah, it is. Very good job. Can you explain how you got that?
So n represents the term number.
Great.
You times 4 by n, and then add 1 each time.
Okay.
If it's increasing by 4.
It's increasing by 4 each time, right?
So if you have a linear equation, whatever number you increase by, you put that before the n.
Yeah,
and
good.
then add whatever number remains.
That's right. Very good job. Very smart. So that's definitely one way to do it. So what Lydia was saying is we take the 4 and we multiply by the term number. So we can write 4n down here as well. So 4 times n equals to 4, and then 8, 12, and then 16. And then you can write another column if you want to. You could call it the difference, and you can subtract these two. 5 take away 4 is 1, 8 take away 9 take away 8 is 1. You'll notice that it's always 1 off. So that means the general formula needs to be 4n plus 1. Okay. Another way I tell students that they can think about it is, because if you do it this way, you need to figure out what 4n is and then take the difference in order to solve it. You can also figure out what the term 0 is. Okay, so this is a plus 4 pattern. So term 0 is technically plus 1, right? It's just 1. So if you wanted to, you could just write 4n plus 1. This plus 1 over here always represents the term 0. Okay, this last term over here. So that's another way of doing it, depending on how you want to think about it. But a lot of the times I would prefer to just figure out what the term 0 is because I think it's faster. Okay, let's try a different one. This time I'll try to subtract it properly. So I do apologize. Let's do 33 and let's do a minus 6 pattern. So 27, 21, and 15. So this is a minus 6 pattern. Who can tell me the general term for this? In other words, the algebraic expression. So remember, we follow the same rule. We use the -6 and we put it in front of the n right away. Okay? If it's a linear sequence, it's always going to be -6n something. So who can tell me what goes at the end? This is really the only question. The -6n is a given. Who can tell me what is the constant at the end? Is it +4, -3? What number am I looking at? Oh,
-6?
-6? Did I hear -6? So let's try it. Remember, anytime we create these expressions, you can check it to see if it works for you yourself. So -6n, if the first term is 1, then that means we have -6 -6. So that gives me -12. So that's not equal to 33. So unfortunately, it's not -6. So whenever we do these expressions, you need to double check it by testing the equation yourself afterwards to make sure it works. Okay? So unfortunately, that's not the right answer. Think about what we said before. If we know that it's going to be -6n something, we can do -6n here right away, and then we can start writing the numbers, right? Remember, this is our term 1, 2, 3, 4. So -6n is -6, -12, -18, and -24, right? Now you can figure out the difference between our value and the -6n. +39 is the right answer. Good job, Evan. I sort of don't get how you check it. Okay, so Sherry, the easiest way to think about it, if you have a linear pattern and you don't know how to, and you don't understand that way, do you understand if we can go backwards to term 0? Does that make sense, Sherry? If we go backwards to term 0? So in other words, this is a -6 pattern, right? So if we go backwards, we need to +6, so we get to 39. Does that make sense, Sherry? Is this a different Sherry that's asking in chat?
That was me.
That was you? Okay. So does this make sense? If we look for term 0, so this is term number 1, right? This is term 2, this is term 3, this is term 4. If I asked you in theory, if there was a term 0, what would the previous term be? What would term 0 be? Well, it's obvious, right? We just add 6.
Yes.
Yeah, so that's it. So now we have -6n plus 39. So that's going to be our formula. Okay, this last term always represents the term 0. Does that make sense?
But why do you have to find the, what's it called, the 39?
Why do we have to find this +39? Because if we don't do it, we won't be able to get this expression. So right now we have this expression, -6n plus 39. So for example, when we want to find the first term, n equals to 1, we could check it. -6 times 1 plus 39 is equal to 33, because that's -6 plus 39. So that's correct. If we want the second term, we get 27, because it's -12 plus 39. So that's 27. So that's correct as well. So this way, we don't have to list out the entire pattern. If the teacher asks you, what is the 100th term in the sequence? I don't want to list all 100 terms, right? It's really long. So all you have to do now is -6 times 100 plus 39. So that's -600 plus 39. So our final answer is -561, right? So we know that the 100th term in this sequence is -561 without needing to label all of it. Okay, so it's really important for us to be able to identify how to get these equations. And there's essentially 2 ways to do it. I think it's easier to just think about the term 0. So in other words, we go backwards and find term 0. You won't always be able to find term 0 because sometimes maybe they'll tell you the 5th term and the 6th term in the sequence. In which case you're stuck. There's nothing you can do. I don't want to go all the way back.
Teacher, for the 4, 10, 18, and 28 pattern,
Yep.
I found a pattern. So it's times 2 plus 2 times 2 minus 2 times 2 plus 2 times 2 minus 2 and so on.
Oh, very clever. So you're saying it's this number times 2 plus 2 and then times 2 minus 2 and then times 2. That doesn't quite seem to work. So 4 times 2 plus 2 is 10. 10 times 2, but then all of a sudden you're minusing 2.
And then it's times 2 minus 2, and then it's times 2 plus 2.
And then it's times 2 plus 2, but 18 times 2 is 36, plus 2 isn't 28.
Oh,
It's 38.
Oh, silly me.
Silly you. That's okay. It's just a silly mistake. I made that mistake too, right? Sorry, Lydia. Go ahead. You get it now?
Isn't it just +6, +8, and then +10?
That's right. So you notice that over here, if this is a +6, +8, +10 pattern, you know this is a non-linear pattern, right? So for non-linear patterns, what we learned just here doesn't actually work. Remember, this only works if we're linear patterns, okay? So in other words, when the difference is always a constant number. What you'll notice for these type of patterns, for non-linear patterns, is you take the second difference. This is something that you don't learn in elementary. You usually only learn this in high school. But what you could do is you could take the second difference again. So this difference between the set of numbers is called the first difference. This is the first difference. So in other words, this is the first difference. We could take the second difference and see if it's a constant value. You'll notice that between 6 and 8, it's 2, and between 8 and 10 is 2. So you start to notice that the second difference is always a constant value, right? The second difference in the pattern 4, 10, 18, 28 is always the same. And that means our answer is going to involve n squared somehow. It's guaranteed to involve n squared, okay? So that's how we can tell kind of the first step towards figuring out our patterns for nonlinear patterns. If we can get a constant difference for the second difference, then we know it's going to involve n squared. Similarly, if the third difference is the constant, then it's going to involve n cubed somehow, okay? So this is kind of a little trick that you can remember, that whatever is the finite constant difference, that's what we call it. So if it's the first difference that's consistent, it's going to involve just n, because it's n to the power of 1, okay? If it's the second difference that's consistent, it's going to involve n squared. If it's the third difference that's consistent, it's going to involve n cubed somehow, okay? So we know this, if we wanted to find the equation for this one, it's going to involve n squared in order for us to find the algebraic expression. Generally speaking, at the grade 8 level, you won't be expected to find these. Usually, you're only going to find linear patterns like this one. Okay, so we'll try one more with a linear pattern, and then we'll talk a little bit more about this later on. Okay, let's try one more just to make sure everyone's fully clear on it. Let's do something like 7, and then, I don't know, let's just add 4 each. Oh, no, let's just add 3. It doesn't matter, right? Okay, who can tell me the general formula for this one? In other words, the general term or the algebraic expression, whatever you want to call it. Yep, Sherry?
Just add 3.
Add 3.
From 7.
Yeah, start at 7, add 3. So that's how we express it in words. Can you tell me the algebraic expression now?
Would it be 3?
Yeah, 3n. I heard 3n. Plus. Good job, Jerry.
Wait. Plus. It has to be.
I think I heard it.
Plus the.
I think I heard you say it. Yep, good job, Evan. So it's 3n plus 4, right? Because our term 0 is 4.
Yeah, it's 4.
Let's take away 3, right? Yeah. And again, you could check this with the formula to make sure it works for all of them, and it will. So the general sequence is quite easy for linear patterns. Generally speaking, I like to find term 0. If ever you don't have term 0 available to you, you still know that this is going to be 3n, right? So 3n is going to be 3, 6, 9, 12. And then you could take the difference between these. You could look at the difference. The difference is always 4. So we know that it's going to be 4 more than 3n. So therefore, it's 3n plus 4 gives me this number. 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 Okay? So that's how we find the general rule for linear patterns. It's quite straightforward. Linear patterns are, generally speaking, the easiest ones. And that's what you're going to be learning in grade 9 as well. Okay? A lot of the times with linear patterns, the next thing that you guys will learn in school is what it looks like on a graph. And like many of you have kind of already expected, because the name is a linear pattern, it's always going to look like a straight line, right? So for example, if we go back to the example with 7, 10, 13, and 16, and we know that this term number is 1, 2, 3, 4, we could technically make a graph, and then you'll see that it's going to look like a nice straight line, okay? So again, this is not perfectly to scale, so you guys will have to forgive me a little bit. Okay, so this is close enough. So we have 1 and 7 as one of the points. And then the other point is going to be at 2, 10. And then 3 and 13 and so on and so forth. And then you'll notice that when we connect these lines, it makes a straight line. Okay, so this basically tells you what this pattern would look like in graphical form. Okay, and this is what you're going to be learning in grade 9. In grade 9, you'll learn the equation of this line, and you'll always know that as y equals mx plus b. But it's the same thing as what you learn in grade 8. That's why I do think this concept is a little bit more important, and I wanted to go over it, okay? So now let's take a look at this pattern. We know that this pattern is a non-linear pattern, like I said. Linear just means straight line, okay? Or the first constant difference is you'll have a first constant difference. So this is a non-linear pattern. So over here, we can see 2 student solutions. You see this person by the name of Cho, and there's a person by the name of Amar. Cho thinks that this pattern is equal to multiply the terms of the sequence 1, 2, 3, 4 with the respective term in the sequence 4, 5, 6, 7. So he says it's 1 times 4, 2 times 5, 3 times 6, 4 times 7. This person is very clever. I wouldn't have thought about it this way. So this Cho person is very, very clever. Amar's solution is what I would have done because I know it involves n squared, so it's a little bit easier. Amar says that what you need to do is you need to add the terms of the sequence 1 squared, 2 squared, 3 squared, 4 squared with the respective term in the sequence 3, 6, 9, 12. So he has 1 squared plus 3, 2 squared plus 6, 3 squared plus 9, and 4 squared plus 12. This is closer to how I would think about it. If any of you think about it the way that Cho did it, very good. But the final answer comes out to be exactly the same thing. Okay, when we talk about the general expression, it's actually the same. So let's take a look. So again, we have Cho's pattern and we have Amar's pattern. Both of them work for this sequence. They're both correct, okay? It says if this pattern continues, complete the next 2 rows of the table. So who can help me complete the next 2 rows of the table first? Who can tell me what's my value for term number 5? Yep, Sherry.
5 for Amar's pattern.
Yeah.
Would be 5 to the power of 2.
Yep, 5 squared plus.
Plus 8, no, 15.
15, right? I heard you say it. Good job. So the next term should be 40, logically speaking, right? And again, we could figure it out from here too. It's a plus 6, plus 8, plus 10. So logically speaking, this one's plus 12, and that makes sense, right? And then the next ones people already answered is 54. Good job. Plus 14, right? Very good. So again, this one will be 6 squared plus 18, and you'll notice that it does give you 54. Same thing with this one. This could be 5 times 8, and this would be 6 times 9, okay? So both of their patterns are absolutely correct. So now it's asking, find the general term for this sequence using Cho's pattern and Amar's pattern. Who can tell me the general term for, let's start with Amar's pattern. I think it's easier. So let's start with Amar's pattern, and then afterwards, we'll see if people can tell me the pattern, the general rule for Cho's pattern. You'll notice they work out to be exactly the same thing. So it doesn't matter how you analyze this pattern. There's multiple ways of us finding the same answer. Yep, Sherry. Oh, Lydia.
N squared plus 3n.
N squared plus 3n. I think that's correct. Very smart. And you notice that is because the term for the first one is going to equal to n squared. And then for the last term, we multiply 3 by the term number. So this is correct for Amar's pattern. Very smart. So this is Amar's pattern's general term. So this is the equation. We got one of the equations. Who can tell me the general term for Cho's pattern? How did Cho figure out his pattern? What's 1 times 4? And then 2 times 5, 3 times 6, 4 times 7, and so on and so forth. What's the general term for Cho's pattern then? Yep, Lydia again.
N times n bracket, sorry. Yeah, n times n bracket n plus
right?
1.
N plus 1?
n times bracket n plus 1.
Not plus 1. Why would it be plus 1? It should be
Wait,
plus
sorry,
3, right?
plus 3, yeah, plus 3.
Yeah, okay, good. Because what Lydia notices, well, the first term is always just equal to the term number, so that's just n. For those of you who don't know, maybe you're a little bit younger, the bracket represents multiplication, okay? And then she noticed that the second term is always the term number plus 3. So she said that this is equal to n times n plus 3. Oops, sorry, I think there was somebody who needed to join. I clicked the wrong button by accident. Okay. So you'll notice that these two equations are both correct, and they're actually the exact same thing. I don't know if, for those of you in grade 8, you probably have already started to learn about multiplying monomials by binomials, but you'll notice that once we expand this, we get the exact same expression. It's n squared plus 3n, right? N times n is n squared. N times 3 is plus 3n. So therefore, the two expressions are equivalent. So they're both correct, okay? So that's an answer for number 3. Are the general terms for the two patterns equivalent? They are equivalent, okay? It's just one is in factored form and one's in expanded form. So there's absolutely no difference. So you can see that there's multiple ways for us to solve for these answers. Personally, I wouldn't analyze it this way. I would just take the constant difference. So I know that this is 6, this is 8, this is 10. And then I'll take the difference again, and I see that it's going to be a 2 and 2. So I know it's going to involve n squared somehow. So what I'll do is I'll list n squared here. So that's 1, 4, 9, and then 16. I'll take the difference, and then I notice the difference is 3, 6, 9, and 12. And then I know that this is n squared plus 3n. Okay, so this is how I would do it. I wouldn't bother kind of analyzing it and breaking it down this way. I would usually start off by taking a constant finite difference to see if it works. Okay, that's how I do. But everybody does it a little bit differently. And there's no right way or wrong way to do this. Okay, generally speaking, again, in school, you're not going to be asked to find nonlinear patterns. If you can just understand how to find equations for linear patterns, that's more than enough already at the grade 7 and even the grade 9 level. Okay, all you have to do is recognize that the constant term at the end represents term 0. Okay, that's kind of just the most important thing that you can learn. If you take away anything from this lesson, is that the last term of the sequence for a linear pattern represents term 0. Okay, represents, well, the y value when x is equal to 0. That's all you have to know. A lot of the times when you guys are in school, they'll provide you guys with drawings instead of numbers. It's exactly the same. There's multiple ways of solving for it. But I usually, my personal preference is I just count the number of posts and just write it down as a number pattern. And then afterwards, it's very easy. This is obviously a +4 pattern. And again, if everything's +4, then term 0 is 1. So my final equation is 4n plus 1, okay? Again, it depends on how you want to think about it. I like to think about it that way. You can do the 4n and calculate the difference as well if you want. It's entirely up to you what you prefer. But some students who are very, very clever, they break down the post into horizontal posts and vertical posts. And then they recognize that the horizontal post follows a pattern of 3n, and the vertical post follows a pattern of n plus 1. So 2 posts, 3 posts, 4 posts, 5 posts. So this final thing becomes 3n plus n plus 1, because n plus 1 is the number of vertical posts, right? 3n represents the horizontal post. But you'll notice that it comes out to be the exact same thing, because 3n plus n is equal to 4n, right? Hopefully all of you know how to group terms. So again, for those of you who don't know how to group like terms for variables yet, you'll probably come to it eventually once you start doing a little bit of algebra in grade 7. It just means maybe you're a little bit too young for this lesson. Okay, so we end up with 4n plus 1. It's the exact same thing. I never think about it this way, if I'm being perfectly honest, because this just seems overly complicated to me. I always just take the constant difference and then just add the term 0. I think this is the fastest way for any linear equation, okay? It's up to you ultimately, okay? I don't want to tell you what is the right way, what's the wrong way. And then they're saying that, well, there's somebody who's even more clever. They can figure it out another way. I would never think about it this way once again, okay? So again, they're saying that this first term contains 5 posts, then we add 4 each time, right? So what happens is it's gonna be 5 plus 4n minus 1. But you'll notice that with this, it's still the same thing. It's 5 plus, we have to distribute the brackets. So this is 4n minus 4, which works out to be 4n plus 1 anyways. Okay, so it's the exact same thing. If your teachers in school will probably ask you, try to write this, the general term in 2 different ways. And then this is kind of an example of how we can write it in different ways. But ultimately, to be honest, at the high school level, you have to write it this way. If you're at the high school level, you write it this way, it's a little bit awkward. Nobody would write it that way, okay? So they're all the exact same thing. They're all equivalent. But if I'm being honest, I would prefer this answer. I don't like this answer or the second answer, okay? Because this answer is the easiest for me to identify. And at the high school level, you'll realize that this equation is very useful, the 4n plus 1 equation, because this tells me what the graph is going to look like right away. Okay, remember we said that the plus 1 always represents term 0. So therefore, I know that the x is 1 already. So the graph is going to look something like this, even without me plotting down the table of values. I know that term 0 is going to be 1. So in other words, when x is equal to 0, y is going to be equal to 1. And I know that this is going to increase by 4 because it's a 4n pattern, right? So I know it's going to increase by 4. So I already know that this graph is going to look something like this. Whereas if you give me this equation, I won't know what this graph looks like. I'll have to actually simplify it to this one before I can draw it. So generally speaking, if I were you, I would recommend writing this equation, okay? The easiest one is the best one. That's just my recommendation. You guys can do it as complicated as you want, okay? I don't have any particular preference for how you want to do it. Let's take a look at, so again, this is a linear pattern. It's adding by 5, term 0 is 2, so it's 5n plus 2, so it's nice and easy, okay? Again, we're not gonna go over perspective 2 and 3 because I think it's way too complicated. If you guys like to break it down this way, feel free to do so. I'm not smart enough to break it down that way, okay? I just like to do it the simple way, okay? I think it's the easiest. So let's take a look at this one. Who can tell me the answer for this one? Oh. Scroll up a little bit. So it says, select the expression that could represent the general term for the number of toothpicks in the following sequence. Who can tell me what is the best answer for this one? Yep, Sherry. So again, we have 3 toothpicks, 5 toothpicks, and then 7 toothpicks, okay? Can you tell me what the general expression is?
3n 2.
Sorry, could you repeat that?
3n plus 2.
Not 3n, remember, it's a plus 2 pattern. So that means the 2 goes in front of the n.
Right.
So it's 2n.
Plus 3, right?
Not plus 3, remember we want the term 0. So it is plus 1, right? And now you can double check this because when n equals to 1, we have 3 toothpicks. When n is equal to 2, we get 5 toothpicks. When n is equal to 3, we get 7 toothpicks. Does that make sense, Sherry?
I think so,
Yeah, so remember the last term is always term 0. So now the question is really which of these is equivalent to 2n plus 1? Because we know this 2n plus 1 is not one of the answers here. We don't have 2n plus 1. So which one of these is the same as 2n plus 1? Which one of these is equivalent?
Maybe D or
D. It's definitely not D because over here, D, you see this is n plus 2n, Wendy. N plus 2n means it's 3n. So that's 3n plus 1. So that's definitely not this one because we can group these two together, right? So D is definitely not part of the something that we should be considering. Which one?
C.
B?
No, C.
C. Okay, so let's take a look. So we have 3 plus 2n plus 1. So again, that gives me 3 plus 2n plus 2. And that actually leaves me with 2n plus 5. So it's not C either. So remember the distributive property, okay? Angela says it's B. So again, we have n plus n, which is 2n. So that's 2n plus 2. So that's unfortunately not 2n plus 1. So that means Lydia, the answer is pretty obvious.
First of all, it's the only one available, and also
Yes.
A is the only one that fits for the first one.
That's correct.
The first pattern.
She's very smart. She actually just plugged in n equals to 1 here, and then she just checked it to see if it works, right? So what happens is we have n minus 1. So she did 1 minus 1, which is 0. 2 times 0 is 0. So 3 plus 0 is 3. So she noticed that this is the only one that works. So therefore, it must be A. So that's very clever. And again, we can still apply the distributive property. And that's when we multiply the monomial into the binomial. You didn't pay attention to the 2. That's okay, Angela. Everyone makes mistakes, right? I made a mistake. The first question that we did, I made a mistake, right? So it's not about making mistakes. It's about whether or not we can learn from our mistakes, okay? And again, we have 3 plus negative 2, which is positive 1. So we have 2n plus 1 over here. Does that make sense to everyone? So these two expressions are equivalent, okay? This is equal to 2n plus 1. So our final answer should be A. So again, they're saying A is the correct answer for this one, okay? Because they're the exactly same thing. I don't think about it as 3 plus 2 times n minus 1. You could think about it that way if you want to. You start off at 3, then we add 2 toothpicks each time, and we multiply by the turn number minus 1. I never think about it this way because at the high school level, you're always going to be using the general formula y equals to mx plus b. So it's just easier for us to think about it as y is equal to 2x plus 1, where b is the term 0. Okay, this is kind of like a shortcut in my opinion. This is how I do it. Again, it's you choose whatever method you want. I've seen teachers teach this incorrectly in school, so you have to be a little bit careful. Okay, I have a student who told me that the teacher teaches them that this is term 0, and then this is 1 and this is 2. This is wrong. Okay, if your teacher's teaching it this way, you might have to do it that way in school just to satisfy them. But that's not true. That's not correct. Okay, this is term 1, this is term 2, this is term 3. Okay, there's 3 pictures. That means this is term 1, 2, 3. I don't know why the teacher is teaching them to start at term 0. That's incorrect. Okay? So watch out for the sequencing. This is, if you understand the linear sequence for this, you're gonna have a much easier time in grade 9 math. Because this is basically all you do in grade 9 math. There's like 3 chapters dedicated to just linear patterns and how to graph them. It's like half of your grade 9 math is just doing this. Okay, so if you understand how to do this really well, it's gonna help you a lot. Okay, so that's why I think this is the most important chapter for grade 8. Although teachers don't seem to focus on it a lot. So let's try this one. Select the expression that could represent the general term for these number of dots. Who can tell me what is the best answer for this one? Again, we have 5 dots here, we have 9 dots here, and we probably have 13 dots here, right? So what is the best equation for this one?
Actually, we have 10 dots, I think.
Which one has 10 dots? This one? No, this one has 9, right? This is 5, and then there's 2 here, and there's 2 here, so this 9.
Wait, so it doesn't, oh yeah, it doesn't count the middle one.
You do count the middle one, but it's 1, 2, 3, 4, 5, 6, 7, 8, 9, right? That's 9 dots,
okay.
Not 10 dots, okay? Be careful. So who can tell me the general term for this one?
+4.
+4, good. So again, you're still telling me the pattern rule in words, Sherry, and that would be start at 5 + 4 each time. How do we write the general term? So when we say general term, it's always talking about the algebraic expression. So sometimes your teacher might just say, give me the algebraic expression. Sometimes they might say, give me the general term. They're interchangeable. Okay, is that D? Yeah, very smart, Angela. Good job. So Angela already answered this one for me. She said it's D. And it's the correct answer because we have a +4 pattern. And Angela realized that term 0 is 1. Right? So it's 1 + 4n, or 4n + 1. At the high school level, if you write it this way, I'll take off half a mark. Okay? So if you write 1 + 4n as your pattern rule at the high school level, I'll take off half a mark. You have to write it as 4n + 1. Okay? The reason being is because of math notation. We always go in math notation from the highest degree to lowest degree, okay? So this is technically 4n to the power of 1 plus 1 times n to the power of 0, right? Because anything to the power of 0 is equal to 1. So that's why this is 1 times 1. So we always have to write it from highest to lowest degree. So in other words, if we write something like this, 4n squared plus n plus 7, this would be going from highest to lowest degree because it's power 2, power 1, power 0. Okay, so it goes from highest to lowest degree. This is considered the right way to write it. If you write it like this, 4n squared plus 7 plus n, while your final answer doesn't change, you'll lose half a mark for this because you didn't write it in proper math form, okay? You cannot, so this question, they shouldn't have wrote it this way in preparation for grade 9 because we shouldn't write the math this way. We always write it from highest to lowest degree, otherwise you lose half a mark at the high school level. Elementary level, teachers don't seem to care. So elementary level, you can write whatever you want. You can write these more complicated ones if you want, it doesn't matter. Your teacher will probably accept it just the same. But I'm telling you right now, at the high school level, write it from highest to lowest degree, okay? So in other words, 4n plus 1 is the correct answer. 1 plus 4n is the 50% answer, okay? You'll lose half a mark. Good job. So again, this is just a different perspective of how they want to think about it. This is another way of thinking about it. They say that we keep the 1 in the middle and we add 4, then we add 8, then we add 12. So obviously they figured out a pattern. This is 1 plus 4 times n. Okay, so this is how they thought about it. It's very clever again, but my personal opinion is that it's still easiest to just convert it into numbers. But it's up to you. If you're a visual learner, you might like to think about it this way. Okay, so it's 1 plus 4n. I don't have a preference on how you do it. It doesn't make a difference to me. So we have 5 minutes. Oh, how much more? 7 minutes left. Let's do some practice questions. Start off with number 1. Which one of these following pairs of expressions are equivalent and justify your answer? So this is just really a practice in grouping like terms. Who can tell me which ones are equivalent? Which ones are the same? We have 5n plus 3 and 7n plus 2 minus 2n. Are these two the same? C. So Jerry says that C is the same. Very clever. So everybody got this answer in chat. So everyone who typed it in chat, very good job. Because 4 times n plus 6, if we use the distributive property, 4 times n is 4n. 4 times positive 6 is positive 24. So this is equal to 4n plus 24. So these two are equivalent, okay? These two are not equivalent because when we group the 7n and the minus 2n, this gives us 5n plus 2. This is 5n plus 3. So we see that the constant term is different. Same thing over here. This one doesn't even have a constant term. Okay, this one's just 5n. And the n value is completely off too. So there's nothing that's correct about B. B is just completely off. So our final answer is C. Okay, very good job. So this is a good practice for what you're going to be doing in school. They want you to write 2 different expressions to represent the general term. Again, they're not really different expressions. They're technically the same. Once we expand it, they're equivalent. But your teachers in school will be asking you, can you write this pattern 2 different ways? Okay, so they're giving you a hint over here. They're saying that this is a pattern with blocks. So you have a 5 block, we have a 7 block, and we have a 9 block. Can you write 2 different equations for it? And they're giving you hints. Like they're saying that, oh, you could think of it as 1 squared plus 4, then plus 6, then plus 8. Or you can think about it as 3 squared plus 3, 3 squared plus 4, 3 squares plus 6. So it's very clever the way that they've illustrated this. Ultimately, the equations are the same. Who can tell me one of the expressions? Wait, how is B incorrect? Silly, I know. Over here, so we have 9n minus 4, and the other one's just 5n. So you see that the 9 is different than the 5, right? And then there's not even a constant term here. This is technically like 5n plus 0. So again, if we tried to substitute for anything other than 1, you probably substituted 1 here, and you realize that they both equal to 5, right? So you thought that's correct. But if you try 2, this is 18 minus 4, which is 14, right? 5 times 2 only gives me 10. So it starts to break down as soon as we try the other term values. So unfortunately, these two are not equivalent, okay? And it's obvious they're not equivalent as well because the numbers are completely different. When something is equivalent, the numbers should work out to be exactly the same after we expand it. Does that make sense?
Yes, thank you.
No problem. So again, don't always just plug in n equals 1, okay? N equals 1, yeah, it might be the same at n equals 1, but even if you try n equals 0, it breaks down, right? This is -4 and this is 0. So remember, something that's equivalent has to be the same for all the term values, okay? For every single possible x term. So who can tell me one equation for this one? Who can tell me the easiest equation for the first one? We have a 5, 7, 9 pattern. Yeah, Lydia?
4n plus 1.
4n, sorry?
4n plus 1.
4n plus 1. Okay, so I don't think that works because if you try n equals to 2, that gives you 9, right? The second term is only 7. So it starts to break down. Does that make sense? 4 times 2 plus 1 is equal to 8 plus 1, which equals to 9. But our term 2 only has 7. So unfortunately, it's not 4n plus 1. Sherry?
Maybe 3n plus 3n plus 2.
3n plus 2. So again, we could try it. Let's try term 2. And then again, we end up with 6 plus 2, which is equal to 8. And again, it breaks down because it doesn't work for our second term. So Kenneth over here says 2n plus 3. And this is the right answer for the easiest one because we know this is a plus 2 pattern, right? Remember, if it's plus 2, we put that number in front of the n. Same thing if it's a decreasing pattern. You just put that number in front of the n. It's always the pattern rule. You put it in front of the n because it's a linear pattern. And then the last number is represented by term 0, which is 3. Okay? Again, if you don't like to think about that way, you could calculate the difference. I don't care. It's up to you. But 2n plus 3 is indeed one of the possible answers. Very good job. Who can tell me another way to express this? And remember, they give you hints with these pictures. So we can say 2n plus 3 is in fact one of them. And that is actually this one. Because we have 3 over here. It's a constant. And for the first one, we add 2 times n, and then 2 times 2, and then 2 times 3. So Kenneth gave me the equation for image number 2. Okay, who can tell me the equation for image number 1?
2n plus 1.
2n plus 1 won't work because we know that 2n plus 3 is the right equation. So if you do 2n plus 1, it's guaranteed to not work. You can even try it. 2n plus 1, it starts to break down even at term 1. That only gives me 3, but we have 5 squares. So unfortunately, 2n plus 1 is not the right answer to express this sequence. 4n plus 1. So 4n plus 1 doesn't work. I think somebody said that earlier, but 4n plus 1 gives me 4 times 2 plus 1, which is 8 plus 1, which gives me 9, right? So it breaks down as soon as we get to term 2. So it's not 4n plus 1. Remember, look at the hints over here. They're telling you that the plus 1 is the constant, right? So again, we start with 1. And then what are we adding? We have a 4, 6, and 8. What are we adding here?
2.
We add by 2's, okay. So what are we adding by? 2 times n plus 1, right? Because over here, for our first term, you'll notice that this is term 1, this is term 2, this is term 3. We have 1, and we need to add 4. So that's 2 times 1 plus 1, which is 2. Same thing with the second one. We have 1 as the constant, and then we add 2 times n plus 1, which is 2 times 2 plus 1, which is 3. So 1 plus 6 is equal to 7. Okay, again, this is a 5, 7, and 9 pattern. And again, if we expanded it, you'll see that these two are equivalent. Okay, 1 plus 2 times n plus 1 is equal to 1 plus 2n plus 2. Again, if you don't know the distributive property yet, you'll learn it in school. And then that equals to 2n plus 3. So these two are equivalent. So on the test, if the teacher asks you to write two different ways of writing it, your first answer should be this one, and then your second answer can be this one. Does that make sense? 1 plus 2 times n plus 1. Because we notice that we can keep the 1 here constant. We can keep this square constant. We can add 2 times the term number plus 1. Okay, that's how we get 4, 6, and 8 over here. Does that make sense to everybody? Yeah? Lydia, you're okay with this? Yeah? Okay. So again, that's just ways of writing the exact same thing. I don't know why they do it this way in elementary school. But at the high school level, you just need to know this one, okay? The easiest one. Remember, it's always just the constant difference in front of the n, and then afterwards add term 0, okay? That's the easiest one. So this is how I would recommend finding the equation. You can find the equation by taking the difference as well. It's up to you. But I like doing it this way. I think it's easy. Okay. So I think that's all the time that we have for today. I hope everyone learned a little bit of something about sequencing and linear equations. This is very important. So try your best to remember how to do it for grade 9. And just understand that the last term always represents term 0. In other words, the initial value. Okay. So that's important for grade 9. It's going to ask you what's that last term represent. It's going to represent the initial value. Okay. So that's it for today, everyone. Everyone can go and have lunch and enjoy the rest of your winter holidays. Okay.